A mnemonic device is something that helps you recall or remember something, with the irony that it's probably the hardest word to remember how to spell. And there are a lot of them out there, some of them useful, some of them frankly ridiculous. In fact, there's one for medical doctors where there's a poem to remember some 24 bones in the foot, and many a wag has pointed out they memorize the bones in order to recall the poem. They certainly can take many forms, visual, oral, meaning how you hear it, or oral, how you say it. You can write them down, that's always a good idea. Not typing, you got to do it manually, kinesthetic memory, if you will. Let's start with an easy one, the capitals of North and South Dakota. They're in alphabetic order: Bismarck, North Dakota; Pierre, South Dakota. Here's another one, the flags that seem almost too similar to recall. We got 3 flags, both of them just red and white. One's smaller, that's a hint. And we've got, Indonesia and Poland. And again, let's use that alphabetic trick. Let's see, Indonesia comes before Poland alphabetically. So how about the colors do the same thing, with red, starting with R, coming before white, starting with a W. And because Monaco in Europe should certainly be different than Poland, and the flag is smaller, the country is smaller, it should be different. Well, here's one, and it's certainly appropriate for mathematics and mandatory in Excel, something called PEMDAS. Parentheses, exponent, multiply, divide, add, subtract. And look at this equation on top. Parentheses come first. Notice the inside parentheses, I have to make it a bracket instead of the round kind. It's kind of actually proper. And we're going to do those first. Then we go to the exponent. That's that up caret symbol. And we'll do that one. Then we do the multiply, divide. Notice you can do one or the other, so they actually go side by side. And then we do the add or subtract. Again, notice they can't do both. You have to do them side by side. And you finally come to your answer. And by the way, guess what? This is a deck of cards with 4 suits of 13 cards. Let's do something a little more useful in another vein, and that is highways. You've got the interstate system, the old federal system. You even have a state one. The state ones don't apply. And, there must be a system to this. And there is, and it's the same for interstates and old federal highways, as well as for European highways, with all of them following the same, probably deliberate mnemonic, which is odd numbers go north and south. Even numbers go east and west. And notice the O's and the E's are uniquely matched up. And they may have 3 digits. In the case of the interstate system in the U.S., it's the first. Happened, by the way, in Europe, it's the 3rd one. But regardless, it's the same. And that is, that even number is a loop, having an even number of nodes. And the odd numbers are, for spurs, having an odd number of nodes. And I bet you know that. Okay, let's step it up a bit. We have statistics useful in finance and investments elsewhere. And we have a mean return, using a Greek letter here for mu, for mean, which is a proper notation for populations, for Greek letters, and we use Latin letters for samples, but let's not dally on that. And so you might sum the returns for each case at time t divided by the number of time periods. That's pretty straightforward. And there's something called the variance, and you take the actual case minus the mean, square it, add it up, divide by the number of cases. Okay? Now, why do we do that? Well, we might not have data that has units, but let's pretend. You know how to pretend. And let's say we have x's and y's, and let's say that x happens to be pigs and y's happens to be dollars. And notice the variance, whether it's pigs or dollars, is pig squared and dollars squared, neither with which exist except maybe if you buy a lot of spam. So we take the square root of the variance returning to the original units. The square root of pig squared, the square root of dollars squared. And that applies to the covariance as well. X and Y, that'd be dollar pigs. There's no such units per se. And now we divide it respectively by both standard deviations, pigs and dollars. All the units cancel and you get the correlation here using the Greek notation for rho. Make it R if it's a sample, for the correlation coefficient. And notice the units cancel. Let's do another one, equally high-powered and useful. We have something called the capital asset pricing model. There it is on the top line. And we have something called the beta. That's a covariance divided by the variance, standard deviation squared. And we can do some substitutions. You get the correlation coefficient times the ratio of the standard deviations. One of my mnemonic tricks is notice when you're standing up, the I is on top. And if you were to substitute the definition of beta, well, you get the correlation times the standard deviation of I divided by the standard deviation of M. And the market premium, that's the RM here. Notice the M's cancel. The I comes out as the units, converting M units to I units. Recalling again that that correlation here, we have it noted as rho. We could call it R. Has no units. With Dr. C.